Hi, everyone. Welcome. It's Pop Goes the Stack, the podcast about emerging tech that insists it's disrupting something. I'm Lori MacVittie, and I'm here to make sure it's not your uptime. Now, this week, everyone's scrambling for GPUs like it's a Black Friday doorbuster, while the real meltdown is actually brewing in your network. Cooling, yes. Power, of course. But nobody's checking on the swarm of chatter from all these conversations that are turning your network into a stress test with a body count. So today, Joel, it's always DNS, Moses is here
You
as
betcha.
usual. And we brought contrarian Ken Arora to argue with us and say, no, it's not the network. I think that's your position. I'm not sure. We'll find out. What we know is that 43% of new data centers are being targeted just for AI. So we're building data center space and networks just for AI. There's really no argument against it creates more traffic and different traffic patterns, but let's dig into why it's important and maybe what we can do about it. Go ahead, Joel.
Sure.
Joel, you start because it's not
Absolutely.
DNS this time.
It's not DNS, although DNS is hugely important to AI as well. But we'll skip that. We'll save that for as a topic for another time. AI networking is definitely important, but it of course it depends on exactly what you intend to do for the AI workload. Obviously, networking is important if you are training models because you have to ingress, analyze, and consolidate a large amount of information into the models that you're building. As such, infrastructure that was built only a few years ago that was mostly based around 10G network, 10 gig networking, really has to be brought up to at least 100 gig standards. And increasingly, the volume of data that some of these training sets need requires that pretty much everything be 400 gig across the board. And that's from going from an old model of constructing a data center with a user load, but a server load that may not exhibit a lot of data transfer characteristics. When you're analyzing data sets, object stored databases, and you're trying to consolidate them into vector databases, networking is fairly critical. Otherwise, your training costs and training times balloon.
So I think a lot of that depends on also that line between what do you call networking, what do you call IO? Where do you draw it? Certainly, training puts a lot of emphasis on inter-GPU communication inside of your cluster for sure. Huge amounts of traffic, whether it's InfiniBand or whether you use, TCP, whatever, it's a huge amount of bandwidth. So as the architect here, there are layers to this, right? This is a NUMA type model. I'm an old guy, so I think of computer architecture terms, right? This is a NUMA type model. Yeah, the closest layer, you're going to have a lot of communication. One layer out, maybe not so much, and then one layer out from there, which is what I'll call the north-south traffic. A lot of trading is pretty self-contained, and so it really depends on what layer you're looking at. And as you said, training is one thing. The other part of the world is inferencing.
Correct.
Inferencing has its own set of requirements. And, if it's everything from completely standalone, which is very, non-intensive in the network and much more interested in your latency than your bandwidth.
Right.
And then all the way to, if you're doing something that's more RAG oriented, yeah, you've got a little more bandwidth, but it's still, I guess I'll end with that ratio is really important. That ratio of GPU cycles to network bandwidth. That's what I look at. And GPUs, Gen AI is very heavy. So you're all of a sudden using a lot more CPU. Are you necessarily using correspondingly more network? Not necessarily, not in many cases.
Okay, so you've got, two different scenarios here. One, obviously, right, training, where you are moving a lot of data across that boundary into this new AI factory, we've been calling them, which is really that data center built out for it because you need the GPUs to do the training. When you're doing inferencing, you don't need the GPUs as much, but my question then becomes, as we start deploying agents, are they going to be in the old data center or are they going to be deployed in this AI factory? Because that changes the impact on the network because now you've got all these weird traffic patterns going on, and they use inferencing at the same time. So you need to consider, right, how is that traffic going to impact the network inside your AI factory, if that's where you put them? Or will people put them in the old data center?
Hmm.
Thoughts?
I don't know. I mean, inferencing, I think over time is going to go increasingly closer and closer to the edge because
Mm.
two reasons. One, the economics of and the curve that GPUs are on, you don't need the latest and greatest, fancy GPU accelerator. Inferencing is a problem that you're going to see increasingly go into more and more mainstream processors. Secondly, for many inferencing use cases and also for agentic, latency is what matters more than bandwidth. You want to get that answer quickly. You've got real-time apps, and agentic just makes it worse because now you're not just making one inference request, you're making dozens of them to come
Mhm.
up with a result. And so latency. And again, I'm going to argue that if I look at it as an architect, the latency of the network may not be the bottleneck. The latency of the actual inference engine may become the bottleneck.
Mm.
Um, but in either case, yes, it's latency more than bandwidth.
It's always
Well,
design.
it is design. Now, I kind of want to take issue a little bit with what he said because the I have to, right? That's my
Mhm.
role.
Yes, yes. All right.
Latency is definitely key, but latency introducing data into the system actually has a magnifying effect, right? So the slower it is to get the data that you need to process, the slower the overall processing time is by a factor of n, right? If just getting the data to the point where it can be inferenced is one piece of the puzzle, and then you may rely on slower GPUs at some point, but just getting the data in the right place for the inferencing to be performed is still a cost that has to be paid. So again, networking is still hugely important there. Latency as a magnifying effect, I think, is one of the things, and we're kind of skirting around this issue, but AI workloads tend to have what we here call data gravity, meaning the data wants to be local or wants to be pulled near the point of inferencing or the point of training. That the efficiency of a system rises the closer it is to the data stores that make up the inferencing decision or are incorporated into the training of an individual model, right? So there's three things that I see. One is bandwidth requirements because you're dealing with a massive amount of data. The other is data transfer considerations, one of which is latency involved in that. And the other is the need for high performance or higher order networking. And all of these things, to me, at least suggest that there is going to be a rapid expansion in the amount of data center infrastructure buildouts necessary just in the networking components, not even talking about the compute necessary for AI.
That's important right there, right? As you were talking, that was my thought. It's like, yes, bandwidth, yes, we're talking about, right, just choke points, is that the old infrastructure, right? It's like putting in a hub. Hey, this will work. Ah, yeah, no, right? People may need to actually upgrade their entire, right, network
Yeah.
infrastructure to make sure that it can handle that and process it. Because if it gets overloaded with too many requests or too much data, either way, right, the processing time on the actual network equipment is going to impact how fast it can, spit it out and
Right.
take it in.
Yeah. So I'd agree with you. And I think with training, I'm kind of there. Data gravity is certainly a real thing, right? And
Yep.
if you've got massive amounts of data, like you look at the training sets for these foundational models, they're immense. They're, terabytes, petabytes of data. They're immense. And yes, data gravity matters. And you've got to put that data as close to the GPU clusters you can. Inferencing, a little bit less so. And for many of the use cases of inferencing, that data can be replicated. It's A, not as big in size, and B, much of the time, not always, much of the time, is something that you can replicate and cache in locations. So I think I can see this going down the path that we saw CDNs go down, if I want to rhyme. That things will get closer and closer to the edge. Some data we push down for RAG. Latency is an accelerant for sure. I mean, is an accelerating factor, but one way to reduce latency is to not have a few monolithic data centers, but to have more POPs where you can do the inferencing. And that's the path I see inferencing going down. it sort of rhymes with CDNs. In fact, there's a paper, I think you can get an F5, Mark Menger authored, I helped him with it, on balancing, data gravity with latency, with power costs, which is another thing that isn't the topic today, but also trying to, when you're deciding where to put your data center, power cost is a big factor. So yeah, data gravity is a real thing, but inferencing latency trumps data gravity, would be my stand.
Yeah. I don't disagree that a lot of inferencing workloads are going to move rapidly towards the edge. We're already seeing that begin to happen. However, there are two other factors, and you mentioned one of them, and that's augmentation. It's retrieval augmented generative, where the data sets that you incorporate are done effectively at the point of inferencing, and included as part of the AI task to perform. The other piece of this is what happens when edge-based AI becomes part of an agentic AI landscape, and where the system itself is initiating outbound transactions and pulling data back over to itself, or remote controlling other elements. Those systems are going to have a need for better and more consistent networking. And a generative AI system at the edge that has an agentic component is not going to be trustworthy if it is only partially capable of reaching the resources that it needs to operate. So from that standpoint, we still need to look at the network transactions even from the edge. The other piece of networking at the edge that I think is really important for AI workloads is making sure that you can securely connect edge AI workloads back to a central hub where they obtain, for example, the models that are deployed to them. And that's a whole other topic, of course, but it does definitely involve how to secure the internetworking between a central AI hub and lots of different edge inferencing workloads.
Yeah, I definitely agree. Security and availability and reliability of those connections matter. So networking matters. I was being more narrowly focused on considering the bandwidth concern. And a lot of those don't need a ton of bandwidth, right? I'm going to update my data store. Maybe it's a database, maybe it's a SharePoint document store. And yeah, I'm going to update that, but I don't need a huge amount of bandwidth. I do need it to be reliable. I do need it to be secure for sure, but it isn't that. And if I can reduce latency, again, I go back to latency, that's really going to help, because I'm going to do that a bunch of times. The flip side, the contrarian in me will say, though, if I'm looking at the latency, and let's say I'm doing some agentic workflow, yeah, it will help me. It'll save me, I don't know, dozens of milliseconds to not have to go to some big data center someplace. On the other hand, how much does that matter if the agentic inferencing is itself going to take 300 milliseconds?
Well, it's additive, I would suppose. So an agentic, I mean, come on. An agentic AI workload is going to consist of multiple transactions, and if you're adding 12 milliseconds to each 300 millisecond round trip, that's still a substantial amount, a measurable percentage of the performance that you're sacrificing by not making sure that latency is absolved.
Yeah. I mean, it is 5 or 10%. I'm not going to throw away, if I can get a 5 or 10% better deal in my car, I won't throw it away, but I'm not going to fundamentally make buying decisions on that.
Yeah. Now, we've been talking about all of these things, kind of glossing over the fact that there's not just north-south agentic AI and RAG transactions or training sets that come from the north-south corridor into a training complex. But when you're doing training workloads, there's also inter-cluster traffic as well. These systems, of course, spread load across each other. They try to create parameter sets by leveraging widely distributed GPU complexes. And the effect of latency there is deadly. Isn't that correct?
Yeah, no, I mean, when you build a distributed system, latency there does become a huge thing. And, I step back a level, and it's really about, when do I decide to do that? What sort of workflows do I do? I mean, again, I think of training as sort of in many ways the complement, but the flip side of inferencing. You've got a huge amount of bandwidth internally, not a lot of north-south bandwidth, and the latency of that bandwidth externally doesn't really matter so much. So that's in some ways is ideal if you can partition the world into small enough chunks. I'll throw something in between if you want to comment on that, which is distillation. Mm-hmm. Distillation is sort of that middle ground between inferencing. And I actually think distillation, building smaller specialized models off of large foundation models, is going to also become quite popular, just as we start becoming more cost sensitive on the cost of inferencing.
Yeah.
That harks back to another topic we've discussed on this program called low rank adaptation, but you can go listen to that one if you like. Let's talk about the east-west or the intercluster networking. There are of course AI networking standards that are built around doing RDMA transactions over things that are not traditionally found in most enterprise data centers. And I'm talking, of course, of things like Falcon or InfiniBand. What do you think about that? Is it necessary to change out your networking simply to pursue the solving the magnifying effect of latency in these east-west transactions?
I think if I'm really interested in training, yes, because training is such. I mean, another ratios matter in all these trade-offs. The ratio of the cost of those GPU cycles versus the cost of networking. Those GPUs, they're this hot. What did Lori call them? The hot thing on sale for
Yeah, the Black Friday
the Black Friday.
doorbuster. Yes.
Yeah, right. I mean, these are pricey things, and so yes, I think that if you're doing training and you're spending $1 billion a pop or more on building a data center someplace, yeah, definitely invest in the things that are gonna help you. I mean, if you even get a 5% or 10% would be great improvement on the efficiency of how you use those GPUs, and they're not idling those extra 5% or 10% of the time. That's, if you invested, $1 billion in GPUs, that's $100 million.
Yeah.
It's a lot, but to Joel's
is.
east-west comment, right? There's, I think we're ignoring two things. One, right? Agents might talk east-west, north-south, southwest, east-west, right? We don't know, right? We anticipate that this will change traffic patterns. That implies there will have to be all sorts of security and access control, right? Mechanisms in the infrastructure that also have to act, which is going to increase that latency and right traffic going back and forth, especially if they're querying like, identity stores or, policy engines, something like that. So you've got not just the traffic that's coming from AI and data, but you've also got all of this other like management traffic that is collapsing into the data plane. So you've got control, you've got all of this in the same plane. That's going to be detrimental to the network if you don't segment and really pay attention to how you're routing.
Yeah. Now, one thing I'd like to point out here is InfiniBand is one of the things that people are doing to assuage the effects of latency. Now, I think that it's probably not such a great idea to choose a completely different networking architecture and standard that is not monitorable or operationalized in the same way that most enterprise data centers are ready to monitor and maintain it, whose physical plant requirements are drastically different than the networking standard that exists north-south. And in the pursuit of what in effect is a couple of microseconds of latency value from a well-designed, say, Ethernet network. We also, of course, have emerging standards. Ultra Ethernet 1.0 spec was just released a couple of weeks ago, which is aimed directly at extremely low latency enhancements to just traditional Ethernet networking. And so I think rushing ahead to try to pursue a couple of microseconds of latency by choosing a completely different networking standard, it just injects a lot of cost into data center infrastructures that in the end analysis, I don't think need to be there in the near future.
Yeah. I was going to say, I think it depends on the use case. I mean, if you're talking about, I just have my companion assistant app, sure, latency, 2 milliseconds is not a big deal. If I'm competitive gaming, yeah, it is. That's the difference between winning and losing right there. That 2 milliseconds, right? You're done. So it depends on the use case.
Yeah. And in the end, it's ROI. Am I better off spending, you're right, Joel, fair chunk of change on saving those few microseconds off, or are those dollars better spent on something else? In the end, if I take the point of view that the GPUs are the precious resource, and I have to do whatever I can to keep them as busy as much as I can, it could be latency, it could be bandwidth, it could be something else, low for a 5, it could just be a better load balancing scheme to say, how do I distribute this workload among the GPUs to squeeze out 5% efficiency? And that might be a better ROI than having to spend a bunch of money on InfiniBand. So yeah,
Gotcha.
I think you're right.
Well, I guess it's time to just talk about the 3 things that we've learned today. And so let me do mine if I could. First, I've learned that bandwidth needs for AI-driven applications are dependent on the application that you're doing, whether it's a training or it's an inferencing workload, and the type of inferencing workload, whether it involves augmented transactions, that makes a huge difference in what type of networking you select. On top of that, though, I also learned that it's data transfer considerations. Data is king in an AI network, and moving data closer to the point of where it's going to be analyzed, or moving data closer to the point where you're going to train with it, is important because it reduces the amount of time it takes to do either of those transactions. And time is key to cost in an AI network. I've learned that the data centers of the future are going to need to take into account the specific needs of AI applications and are going to need to be architected that way. Ken?
Yeah, I agree. I'm going to piggyback on off your last observation. I'll say, and it's more that it is not just all AI applications, all Gen AI apps are not the same. What is your application? Is it latency sensitive? Is it much more training intensive? How much do you use RAG? How much do you use agentic? These are the questions I learned. These are the questions you need to start by asking yourself. And then from there, follow out decisions. From there, you talk to, again, I'm the engineer here, so I'll think about, well, what does it mean? What's my ratio of compute to bandwidth? How much of my latency is being taken up by my AI application versus my networking? What is my utilization of my GPUs? And then I make a decision. I've learned, and then you make the decisions on what to do. And I guess the last thing I think that really struck me is piggybacking off of Lori's comment of a few minutes ago. We need better nomenclature for these things. We're still working our way through it. East, west, north, south. We've had for a long time, a very simple view of this. There's a lot more. Did you mean east, west is intra cluster? Did you mean inside my data center? Did you mean 2 Kubernetes workloads talking to each other? What did you mean by east, west? If we had more time, I would have asked you these questions.
Right.
And but it means that we need better nomenclature. We need the vocabulary to talk intelligently.
Great.
Yes. And I learned 2 things. One, I think, right, I mean, the whole application piece, right? The applications are more important to network design, I think, than they ever have been before. We used to classify them in big categories of, well, web apps, and they need this, and, these other apps, and they need that. But we didn't design networks specifically around the applications. And it sounds like this next move is we have to be a lot more aware of the applications and the resources that they're consuming when we design these networks, and how we implement all of the different pieces that go into that, which is cool. I mean, everybody, gets an opportunity to design a brand new network, and we'll see what comes out of that. And second, that Joel is not a competitive gamer because he thought 2 milliseconds was not important.
So, microseconds, actually. Microseconds.
Even microseconds.
Okay. Lori's got fast reflexes.
Sure.
So fast, right? More coffee. But all right, well, we won't dig into that. That's a wrap for this edition of Pop Goes the Stack. If you dug the beat down, subscribe before disruption disrupts you instead. We'll be here guarding your SLA and maybe your sanity.